Okay, today what I want to talk about is, I want to review um, the worksheet. I asked you guys to did last class, which is about luminosity, temperature, and star. Okay, so as you can see from this slide, luminosity is proportional to the radius squared, and as well as temperature the fourth. But I'm not going to ask you to calculate using this equation, but I want you to understand luminosity of a star is dependent on the radius as well as the temperature. When the radius is bigger, luminosity is going to be bigger. When the temperature is higher, luminosity is bigger as well. So in this tutorial exercise, the first part of this exercise is using the hot plate to cook a spaghetti. So you think about how, if you want to cook the spaghetti faster, so you need a hotter plate, you need a bigger plate, okay? So it's very similar when we talk about stars luminosity. So if you take a look at the second page, so the second page moving from hot plate to the star. So we're using comparison here between the hot plate and stars to help you understand the relationship between luminosity, radius, and temperature. Okay, so if you look at the second page of this worksheet in the middle, it says the time for the spaghetti to cook is determined by the rate at which the hot plate transfers energy to the pot. This rate is related to both the temperature and the size of the hot plate. Okay, so for stars, the rate at which energy is given off is called luminosity. So the luminosity can be increased by increasing its temperature and increasing its surface area. So in other words, if you have a hotter star, you have a bigger star, then the luminosity is going to be bigger. Remember, luminosity is absolute magnitude, which means that the real amount of light emitted by a star. Okay. I think you can take a look at the solutions for this exercise. It's pretty straightforward. If you have questions, please let me know.